Hey everybody. Today we're going to talk about rational numbers. We've been doing a lot of work with rational numbers. We've been talking about whole numbers, integers, fractions, mixed numbers, decimals. These are all different types of rational numbers. A rational number is any number that can be written as a over b, where a and b are integers. So we see in this little Venn diagram here, we see whole numbers like 5, that's a rational number because I can write it as 5 over 1. If I want to show that the number is rational by writing it in a over b form, writing it as a fraction, I can do that with any whole number by just putting it over 1, right? Because 6 over 1, 6 divided by 1 is the same as 6. Negative 2 over 1 is the same as negative 2. And 0 over 1 equals 0. With mixed numbers, all we have to do is convert them to improper fractions. Remember, we can do that by multiplying the denominator by the whole number. We times there, and then we add that to the numerator. And then we can ignore the negative sign until we're done. Try to make that a real plus sign there. Okay, so in this case, 3 times 2 is 6. 6 plus 1 is 7. We get 7 over 3, and we make that negative. See, and now we have 2 integers in the fraction. Our next one, we can do 7 times 3, that's 21. 21 plus 5 is 26 over 7, that's going to be positive. And in our last example, we have 11 times 1, that's 11, plus 4 is 15. Our denominator stays the same, and we're going to put the negative sign in the numerator. We're almost always going to put the negative sign in the numerator. When we're working with decimals, we can write almost every decimal as a rational number, a fraction. But we have to do a little bit more work than we did with the mixed numbers and the integers. In this case, it helps to look at the place value. Here we have 0.64. We have 6 is in the tenths place, and we have 4 is in the hundredths place. So this helps us know what our fraction is going to look like. If we go to the hundredths, our denominator is going to be 100. And our numerator is just what our decimal is, 64. And we can simplify this if we want. I know that 4 goes into 64 and 4 goes into 100. If I do 64 divided by 4, I get 16. If I do 100 divided by 4, I get 25. Okay? With our next example, it's going to be the same thing. We have a 4 in the tenths place, though we don't have hundredths. So in this case, it's just going to be 4 tenths. And I can simplify this. I can divide both of those by 2 to give me 2 over 5. Our third example, we got negative 0.185. Now, in this case, it goes the tenths, the hundredths, and this is in the thousandths. So we're actually going to have to write this one as 185 divided by 1,000, over 1,000. That's our fraction. That's our rational number. We always want to simplify it. Now I see our numerator ends in a 5, and then I know our denominator ends in a 0. And because I know my multiplication by 5s, I know that if anything ends in a 5 or a 0, it's divisible by 5. Now, I don't know what 185 divided by 5 is off the top of my head, but I can figure it out using long division. 5 goes into 1 0 times, but it goes into 18 3 times. 3 times 5 is 15. We subtract there, we get 3, bring down the 5. And I know 5 goes into 35 7 times. 7 times 5 is 35. We subtract, and we get 0. So 185 divided by 5 is 37, and 1,000 divided by 5, I know that that is 200. So there's our rational number, our fraction version of that decimal. If we have decimals greater than 1, we can do the same thing. I have 0.12, that goes to the hundredths. So I'm just going to deal with the fraction first. Well, I guess I could write this as a whole mixed number, right? I can do 3 and 12 hundredths. That's the same as 3.12. Now I just have to simplify the fraction before I go any further. I know that I can divide 12 by 4 and 100 by 4. So I get 3 and 3/25. Now I want to turn this into an improper fraction. I'm going to do 25 times 3, that's 75. Add 75 to 3, and I get 78 over 25. Our denominator stays the same. Oh, you know what? On my example up here, look at this. I forgot the negative sign. I can't believe you didn't say anything. In our next example, we also have a negative. We have to make sure that we get that negative in there. -5 and 35 over 100. And here's another case where I can divide both of these by 5. In this case, it's a little easier because I know 35 divided by 5 is 7. So I get 7, and I know 100 divided by 5 is 20. Now I'm going to change this into an improper fraction. 20 times 5 is 100. 100 plus 7 is 107 over 20. And we'll make that negative. And you know what? We're going to actually skip this last example because I think you got the hang of this. And we're going to move on to changing fractions into decimals, and that can be a little trickier. When we're trying to turn a fraction into a decimal, we can use division, right? That's all fraction is a way to show division. So in this case, I have 3 divided by 4 in my first example. -3 divided by 4, but for now I'm going to leave off the negative. And if I'm dividing by 4, I put my 4 out here, and I put my 3 right here. Okay? Now, 4 doesn't go into 3 at all. So I need to extend my problem. So since that's 3, I'm just going to put a decimal point there to keep the value the same. I'm going to put 3.0. 3.0 is the same as 3. We're not changing the value of the number, so it's okay to do this. And now 4 goes into 30, I know 7 times, because 7 times 4 is 28. So I'm just doing long division here to turn this fraction into a decimal. I subtract, I get 2. Now I'm not done here because I don't have 0 as my remainder, so I got to add another 0. Bring that 0 down, and 4 goes into 20 now 5 times. 5 times 4 is 20. Subtract, and I get 0. So now I'm done. And I just have to bring my decimal straight up and put my decimal right there. So my answer is 0.75, and my original fraction was negative, so I got to make sure my decimal is -2. Right? And that's what we should have expected to see. We know 3 over 4 gives us 0.75. So I want to do that one first so we can see that this works. Our next example, we have 5 divided by 16. This one's going to be tricky. 16 doesn't go into 5, so I'm going to do the same thing. I need to add a 0 there afterwards. Now I know 16 goes into 50. Let's see here. 16 plus 16 is 32, so that's twice. And if I add 16 to 32, I get 48. So 16 goes into 50 3 times, because I added it 3 times. So 3 times 16 we said is 48. We subtract, I get 2. Now I need another 0 here to bring that down. 16 goes into 20 once. 1 times 16 is 16. I subtract, I get 4. Man, I need to add another 0. 0 that I'm going to bring down. 40. Okay, 16 goes into 40. It goes into 40 twice, because 2 times 16 is 32. This is a complicated one here. 40 minus 32 is 8. I'm not done still. Got to add another 0. Bring that 0 down. And we get 80. 16 goes into 80. 16 actually goes into 80 5 times. 5 times, because 5 times 16 is 80. And then we subtract, and we get 0. So we're done, and we just need to make sure we put our decimal here. So our answer to this one is 0.3125. And we started with a positive, so our answer is positive. We should probably be boxing our answers here. All right, last example. Now, here's a case where we have a mixed number. This is actually pretty good because we know our answer is going to be -8 point something. We just got to figure out what is 4 divided by 9. 9 doesn't go into 4, so once again I need to add a 0 here, a 0.0. 9 goes into 40 4 times, because 4 times 9 is 36. We can subtract. 40 minus 36 is 4. Got to add another 0, and I get 40 again. 9 goes into 40 4 times. 4 times 9 is 36. Subtract that, I get 4. Add another 0. Wait a second, I see a pattern developing. I did 40, I have 40 again. Let's see here. 9 times 4 is 36. So it goes in 4 times. You see how I'm just repeating the same thing over and over again? That means that I could really just keep doing this forever. So instead of continuing on, I don't have all that time, I'm going to put my decimal there. And since I know this 4 is going to keep repeating, I'm just going to keep repeating the same operations. So I'm actually going to write my answer like this. I have 8, it's a negative 8 point, and since I know that this 4 up here is going to continue forever, I'm just going to put 4 repeating. And that's my answer. Negative 8 and 4/9 the same as negative 8.4, and that 4 repeats forever. That's it for tonight. I know that was a lot. Finish your notes. Don't forget to submit. I'll see you in class tomorrow.